Okay, so this is a video for homework 8, problem 4, and here we have a problem about fraudulent checks and the first significant digit of the check numbers. So we have this probability distribution known as Benford's law, and it describes the probability of having the first digit be a 1 or 2 or 3 all the way up to 9. And you see here in this problem that I have 217 allegedly fraudulent checks. So they actually went ahead and gathered the data for 217 checks. Now, usually people don't have very much of a problem setting up part A, but the problem comes when we go to get our chi-square knot and our p-value. So I'll show you how to get those using StatCrunch. So first of all, you're going to say click on the icon to view the table. And you can see this is your table here where we have the first digit and its frequency for these 217 checks. And this is Benford's law, the probability for each digit. So you're going to click on full data set and open in StatCrunch. And it will bring your data right over to StatCrunch for you. Now to perform the chi-square test, we're going to press Stat, Goodness of Fit, chi-square test. Now in doing this, your observed is the frequency of each one of the digits that was observed in those 217 checks. So we're going to pick frequency as our observed column. And then the expected is the probability of each one, which is Benford's law. And then click compute. So if you look here, what I end up getting is my chi-square value being 28.80, we'll call it. So let me see what they wanted us to round to here. Clear this. So here they wanted us to round to 3 decimal places, so you see they put 28.801, and that was because this digit here was a 6, so they rounded this 0 to a 1. And then your p-value, they also wanted you to round to 3 decimal places, so this was 0.0003, so they just rounded that to 0.000. And that's how you get those two values. Now, based on that, it depends on which method they're using here, but they're using the p-value approach. Given that alpha is 0.01, just remember that if the p is lower than alpha, if the p is low, the null must go. So if the p is lower than alpha, then we reject the null hypothesis. So given that the p-value is 0.000 and alpha is 0.01, we're going to reject h naught because the p-value is less than the given alpha.